Okay, so welcome to my talk today on expanding your data visualization vocabulary. And the field of data visualization is far more rich and diverse than you would expect. While many people know of simple visualizations such as bar charts or pie charts, there are in fact many more ways to visualize information that are out there. And is everyone hearing me okay? Is everything fine? It's all good? Excellent. Okay. See, we're just getting a few more people coming in now. But I'll carry on. So, for those who've come to this talk out of curiosity and have no idea what data visualization is, here's a simple definition. So, it's the representation and presentation of data to facilitate understanding. And that comes from Andy Kirk, who's an expert and writer on data visualization here in the UK. And I'll give you a bit of background on myself. My name is Severino Rebecca, and I've worked a number of years as a freelance graphic designer. I specialize in information design and on data visualization. Just over 3 years ago, I started a research project, the Data Visualization Catalog. And in this project, what it involved was me researching into the many different types of data visualization that are out there. And I did it as a way to improve my own knowledge base so I could more effectively work on data-focused projects. After I gathered enough research, I published my findings on a website, and I managed to build 60 different reference pages dedicated to each visualization type. After studying each visualization type intimately and then writing about them, I learned a large knowledge base of different visualization types, how each chart is constructed, and to select charts based on what you want them to communicate. So in this talk, I want to use my knowledge to expand your own data visualization toolkit. Through listening to this talk, you should be able to move away from using the same old charts and be more versatile in your approach to data visualization. Develop also some understanding of how visualizations are constructed. Look at visualizations based on what functions you need them to perform, and to see how rich and diverse the design of charts can be. So in this talk, first we'll be looking at the foundational building blocks of what charts are constructed out of, which are the visual encoding methods. Learning this can be useful in your designing of your own visualizations from scratch. Next, we'll look at the various functions you need to consider before selecting a chart. What is it that you want to communicate to people? And then finally, we'll go through a list of different chart types to extend your visualization vocabulary and give you a better selection of tools to visualize your data with. As well as that, I will also try to provide some examples. So let's go through visual encoding, through some examples of visual encoding methods. Charts are constructed based on these visual encoding methods, and they are the building blocks that determine how data manipulates graphical shapes and forms in order to represent the data. The way this works is that values such as numbers, etc., are encoded into graphical language as a way to communicate that data visually. And the first up is position on a scale. So this is using shapes plotted on a one-dimensional scale or on a Cartesian coordinate system with the same scale. So for example, the higher the value, the higher up on the scale the shape is going to appear, for example in these dots here. And the lower values are going to go further down on the scale towards 0. So this is one example of a visual encoding method. Next up is length. So using the length of lines or shapes to display differences. Displaying non-aligned lengths can also affect interpretation here, but it doesn't necessarily compromise it. Next we have direction. So using directional lines with arrowheads or end markers. These are well suited at displaying movement or change. Angle. Using the space between two intersecting lines or shapes that are diverging from a common origin. Area. Using the amount of space contained within 2D shapes to visualize proportions. Volume. Using the amount of space contained within 3D shapes to visualize proportions. Shading. Varying the shades of colors to show differentiation or to show a scale of values. Now, if we were to put these on a scale of their usefulness, on one side we have the visual encoding methods that are more useful for making accurate analysis and to more accurately compare values, while on the other side we have visual encoding methods which are better for more general analysis, for seeing a more big picture of the data. So that's a basic view of visual encoding methods. And I want to look on now what is that we're going to try to show with the data. Different charts are better at communicating different types of data and messages than others. Here's a run through of some of the things that charts can be useful for showing. Comparisons, so that's showing the differences or similarities across the data. Time, showing data changing over time, usually to find trends. Correlations, show a relationship between two or more variables if one variable is impacting another. Patterns, reveal forms or patterns in the data to give it meaning. Hierarchy, showing how things are ranked and ordered together in an organization or system. Connections, show how things are connected. Distribution, show frequency, how data is spread out or how it is grouped. Percentage to a whole, show how data is divided to a total amount. Range, show the variation between upper and lower limits on a scale. Movement or flow, show the change or transfer of values or objects from one position to another. And geographical, show data over geographical regions. So let's look more at charts themselves. How many charts can people name here? Put some show of hands. Anyone can give me any names, charts that they know? No? Off the top of your head? Line chart, pie, bar chart. Okay, so not a huge amount at the moment, which is good. So this is ideal for this talk. So let's look at some charts that most people are familiar with. So somebody mentioned bar charts. So these use the length of horizontal or vertical bars to show discrete numerical comparisons across categories. Then you may have seen in the last talk, Deborah covered pie charts and donut charts. And these help to show the proportions and percentages between categories by dividing a circle into proportional slices. This is used to show a part to the whole relationship. A donut chart is exactly the same as a pie chart, but with the center cut out, which can be used to add text or graphics into, so it can be very useful to save space. You can always add in some of the labels there. Next we have a line graph, and that's used to show trends over time through the line's journey going up and down across the graph. An area graph is pretty much the same as a line graph, just with the area underneath the line colored in. We have here a pictogram chart, and in this chart icons represent a unit. For example, one icon could represent 1, it could represent 10 or 100, etc., which readers can then count, and it's to give a more visually engaging alternative to displaying small sets of discrete data. And then, of course, there's a timeline, which uses points along a line to display a list of events in chronological order. And here we've got a timeline of World War I. But now it's time to introduce you to a whole new visualization of new universe of visualizations, and expand your mind to many other possibilities. So first up is a proportional area chart, and this chart uses the area of any shape for comparing the values and showing proportions, and it's great to give a quick overall view of the data without the use of scales. So in this example here I've used squares, but this could be, you could use this for circles, triangles, etc. And the thing here is just to use size to compare the differences in values. And I have an example here which is used to compare the value of having a large dog and the ecological footprint that has in comparison to a Land Cruiser, which surprisingly is actually a lot more. So each of these squares is using the ecological footprint, and that comes from Good Magazine and New Scientist. Next up is a histogram, which, while it looks very similar to a bar chart, is different in its function. Histograms visualize the distribution of data over a continuous interval or a certain time period, and they help give an estimate as to where values are concentrated, where the extremes are in the data, and whether there are any gaps or unusual values. If I was to categorize it under one of the functions I covered before, it's ideally suited for visualizing the distribution of data. And if you combine two histograms and put them back to back, you can produce a population pyramid. And this chart displays the distribution of population in all age groups and in both sexes. Population pyramids are ideal for detecting changes or differences in population patterns, and multiple population pyramids can be used to compare patterns across nations or selected groups. And we can see that in this example here of the of urban age cities compared. So we have each of these various cities across the world, and you can see that each of these population pyramids have different shapes. And this gives us some insight into the populations that are in these cities. So population pyramids that have a wider top tend to be older populations, while population pyramids that have a much wider base and a narrower top with a more triangular shape, like let's see, maybe one here towards in the bottom, and the bottom right, that tend to have younger populations. And that's one of the main things that this chart is useful for. The next chart is a span chart, and this is used to visualize ranges. So it's ideal for displaying dataset ranges between a maximum and a minimum value, and it uses the length of these bars to visualize that. So the beginning of the bar is the start of the range, and then the end is the maximum value. Here's another variation of a bar chart, which is a stacked bar chart. And stacked bar charts or bar graphs segment their bars of multiple data sets in conjunction of each other. And they're used to show how a category is divided into smaller categories and what relationship of each part has to the total amount. And the total value of the bar, of each bar, is all the segment values added together. So this is ideal in this example here for comparing total amounts across each groups of segmented bars. And here we have a very old example, and it's the statistical diagram of international shipping from J.G. Bartholomew, Atlas of World Commerce. And you can see here for each country the changing between sailing ships and steamships and how they've increased over time. So here we've got blue is used for one category, and then the pink is used for another category, and they're stacked together and also shown over time. Next up, we have a 100% stacked bar graph, and this is used to show the percentage to the whole of each group, and this is plotted by the percentage of each value to the total amount of each group. This makes it easy to see the relative differences between quantities in each group. And in the previous stacked bar graph, you had varying widths, but in this type, in 100% stacked bar graphs, the widths are consistent and they have the same widths. And this is used to compare percentages. And here's an example here showing the marital status between different generations here, and we can see each category. So we've got, in green, we've got married, a lighter green, we've got separated and divorced, and then the lighter, very light, kind of creamy green is never married. And we can see over various generations how the marriage percentage of people married has actually gone down over time. And this is one good example of how this chart can be utilized. And this comes from the data from the Pew Research Center. Next chart is a Marimekko chart, designed, named after the Finnish design company, fashion design company. And Marimekko charts are used to visualize categorical data over a pair of variables. They work as a sort of two-way 100% stacked bar graph. Both axes are a variable with a scale that determine both the width and the height of each segment. And this makes it possible to detect relationships between categories and their subcategories via the two variables. Next up is a chord diagram, and this type of chart visualizes the interrelationship between entities. The connections between entities is used to display that they share something in common, and this makes chord diagrams ideal for comparing the similarities within a dataset or between different groups of data. And here we've got a nice example of that, and it's the close-up genome, species by species, and it shows the large degree of similarity between the first chromosomes of 4 animals, mouse, monkey, chimp, chicken, to that of a human being. And all these lines at the bottom, you've got, let's see here at the bottom right, you have the kind of human beings, and then for each animal, the lines are given a different color. So for one animal, we've got red, blue, gray, yellow, etc. And you can see how the connections between the chromosomes connect to that of a human being's DNA. Next up is a spiral plot, and this type of visualization plots time-based data along an Archimedean spiral. The graph begins from the center of the spiral and progresses outward. Spiral plots are versatile and can use bars, lines, or points to be displayed along a spiral path. And here's an example here showing the space weather data. And this shows how spiral plots are ideal for showing large data sets, usually to show trends over large time periods. And this makes spiral plots great for displaying periodic patterns, as seen in this example, which visualizes space weather data across the year. And color can be assigned to each period to break them up and to allow some comparison between each period, like in this example where each month is colored. Next chart is a scatter plot, and scatter plots are ideal when you have paired numerical data and you want to see if one variable impacts the other. And this is done by displaying a variable in each axis, so to detect if there's a relationship or a correlation exists between the two. So here's a diagram of the various shapes that patterns that can occur in a scatter plot, and this can help you read and understand how they work. And these include positive, so that there's a positive correlation, and this is displayed when values increase together. Or you can have negative correlation when one value decreases and the other increases. So this helps to communicate how two variables impact each other. And if there is no correlation here, you'll get null, which is just a line going across. But then we also have the shape can be described as being linear or exponential or a U shape. The strength of the correlation can also be determined by how closely packed points are to each other on the graph. So the more closely packed all the points are together, the stronger the correlation, and the more spread out, the weaker it is. Bubble charts work in the same way as a scatter plot, but they display an additional third variable through the area size of the circles. And I'm going to show you the late Hans Rosling's Gapminder tool, which demonstrates the wealth and health of nations over time. You see it start off here in the 1800s. And you can see each of these are colored based on each continent. It'll come up to the present day, and you'll see how various nations have increased in wealth over time. Next up is a heat map. And this is another way to find correlations or patterns in the data through the use of heat maps. And here we've got basically a table, and each of the cells are filled in based on the data value. And this can be used in a couple of ways. Here we have heat maps comparing the political views and their opinions on each things. So you've got the various issues and whether people consider them more important or not, or least important. And in the rows we have the issues, and in the columns we have each of the different political factions. And this is a poll that was carried out in the US. So this can be useful to see, to make some kind of insight into the views over different categories. But heat maps can also be used to show the data over time. So here we have from the Wall Street Journal, battling infectious diseases in the 20th century and the impact of vaccines. So each of the squares here visualize the intensity of polio across the US. And there's a line that strikes down through towards the end, which shows you where vaccines are introduced. And right afterwards, you can see from visualizing this data that the vaccine had a huge impact in destroying the rates of polio. Choropleth maps provides a way to visualize values over a geographical area to show variations or patterns. And this is Baron Pierre Charles Francois Dupin's map of distribution and the distribution and intensity of illiteracy in France. So the darker regions are the most illiterate, and the lighter the ones are shown lighter here. So this is one of the very earliest drawings of this particular type of visualization. And another geographical use of the display of data is with a bubble map. And bubble maps are good for comparing proportions over geographical regions without the issues caused by regional area size, as seen with Choropleth maps. And the issue sometimes you get with Choropleth maps is the larger regions tend to kind of dominate over the smaller ones, and this can sometimes make it difficult to read values from. And here is an example of the use of bubble maps recently to visualize exactly where each candidate's cash came from. And this is from Bloomberg Politics. And they've used different colors here from whether they're Republican or from Democrats, and where in the country the donors came from. Next data map is a flow map. flow maps geographically show the movement of information or objects from one location to another and their amount. Typically, flow maps are used to show the migration data of people, animals, and products. And here is an example here, and this is Minard's map of French wine exports in 1864, and it shows you where France is exporting its wine across the world in that time period. A similar chart to that, but without the map, is a Sankey diagram. And typically, Sankey diagrams are used to visually show the transfer of energy, money, or materials. But they can be used to show the flow of any isolated system process. The width of the arrows or lines are used to show their magnitudes or size. And this example here that I've demonstrated shows the energy exchange in a light bulb. So you start off at one end with the electrical energy, and then it's converted into light and heat energy. And you can see this particular light bulb is not very efficient because most of it goes off in heat. Here's a bit more of a complicated example of a Sankey diagram. And this is showing the power outputs in a country and then where that power is distributed in the nation. Another flow kind of design chart is a parallel set chart, which is similar to a Sankey diagram in the way that they show flow and proportions. However, parallel sets don't use arrows and they divide the flow path at each displayed line set. Each line set corresponds to a dimension/data set, which its values/categories are represented in each line divided in that line set. And the width of each chart and flow path that stems from it is determined by the proportional fraction of the categories total. And each flow path can be colored to show and compare the distribution between categories. And in this example I've shown here, we can see the breakdown of Titanic Survivors. So the people that survived are colored in the blue, and the people that perished were colored in orange. And in each line break, they've divided it down based on sex, whether they're male, female, age, whether they are child, adult, and also they broke it down by the class as well in the cabin. So first class, second class, etc., and also the crew as well. So you can see what percentage and what chunk of the people that were aboard the Titanic who perished and who survived the most. And next up we have a tree diagram, and this is a way of visually representing hierarchy in a tree-like structure. And in this example here we've got I've displayed the structure of an organization or a company. There are also Icicle Tree charts that can visualize hierarchical structure, and here we've broken down the categories of various animals. So we've got mammals, which is broken down into canines, rodents, felines. Canines is broken down into dogs, foxes, wolves, etc. And so this is another way to visualize hierarchy. And then tree maps are an alternative way of visualizing the hierarchical structure of a tree diagram, while also displaying the quantities for each category via their area size. And each category is assigned a rectangle area with their subcategories nested inside of it. And here's an example of The Force Awakens, how much money they produced in revenue worldwide. And so each block is the amounts there. and this is from Bloomberg. But we can also change this and convert it into circles with circle packing. So circle packing, also known as a circular tree map, is a variation of a tree map that uses circles and contains within each of these circles represents a level in the hierarchy. So imagine now in the next data set that you have to communicate to an audience. With the knowledge you've gained today, you'll be able to select from a much wider range of charts. Also, I hope that you've seen that data visualization is an interesting and creative field, not just something relegated to statistics. Maybe you'll also be inspired today to create your own chart after seeing the possibilities available. So thank you for listening, and let me know if you have any questions. So you just put your hands up, and if you've got any questions to ask me. I'll also, also, I have a website as well, which you can find a list of different charts as well. You can follow me on Twitter, where I post the latest news and research on and some interesting examples. I also have a Facebook page that I update. And on the YouTube channel, I have a series of visual guides teaching you on different chart types. Oh, hi.
Do you create most of your charting in Excel?
No, I actually use typically Illustrator. So have you seen in Adobe Illustrator, you can also draw charts. You have the graph tools. Some I do from scratch. There's also a list of other tools like d3.js, Tableau, R, which you can generate charts from instead of having to draw everything manually. Hi.
So for these kind of like more complicated things with a lot of data states like chord diagrams and spiral plots, what would you use to actually create those designs?
Something maybe like the spiral plot. There's some code, I think, but I believe online. It would have to be generated with code. I think to do on Illustrator would be quite difficult to generate this kind of chart. But there are, if you're familiar with programming, you'll be able to draw from there. But I also have on my website links to various pieces of code or software that can generate those charts for you as well. And there's also a website by Andy Kirk called I think it's the Chart Makers Directory, and he has a list there of all various software websites and coding language you can use to generate different charts.